Let's just look at chapter 2.1. You have the L'Hopital rule and the limit of indeterminate form. There are four types of indeterminate form. The first is the equation, second will be the product form, third will be the differentials, fourth will be the power. Let's just look at the first type. The first type means that you see that you have a form of 0 over 0 or you have infinity over infinity. So that is the time you're going to apply L'Hopital rule. For the second type, you will have a product form that means that you have 0 multiplied with infinity. So the first step in solving is actually you have to either apply this one or you apply this one. So it means that you have to drag out the g become 1 over g, or you drag out the f become 1 over f, manipulate them such that you get back quotient form, and then you can apply L'Hopital. The third one is the differences. You have the infinity minus infinity. So the first step is you have to apply some algebraic manipulation such that you can get back quotient. So you can apply L'Hopital. The fourth one will be the power. So you will see 1 power of infinity, or you have 0 power of 0, or you have infinity power of 0. So the first step is you have to apply logarithm to them and then manipulate them until you're able to get the equation form, and then you apply the L'Hopital and you solve them. What is L'Hopital rule? L'Hopital rule says that if you have the limit x approaches to a and you have the function f over function g and they are in indeterminate quotient form, then you can say that this limit is actually equal to the limit of x approaches to a f prime over g prime. What is indeterminate quotient? Indeterminate quotients, that is, you have in the form of 0 over 0, or you have infinity over infinity. So let's just go to the first step. So the first step, you have indeterminate quotients. That is, either you will see the form of 0 over 0, or you have the infinity over infinity. Whenever you see this type of quotient, so you will have to apply L'Hopital rule. So let's just look at the first example. So the first example, you have the x approaches to 1. So what happened? You have this limit. So you're going to substitute the x here, you're going to substitute the x here. So you have ln 1, and at the bottom you have 1 minus 1. So ln 1 will basically give you 0. 1 minus 1 is actually 0. So then you have a form of 0 over 0 that is in the form of the indeterminate quotients, this one, the first form. So what you have to do is you have to apply L'Hopital rule. So we're going to apply L'Hopital rule. So how to apply L'Hopital rule? The way to apply L'Hopital rule is actually very easy. So you have to differentiate the numerator and the denominator. So if you differentiate the ln x, so you will have 1 over x. If you differentiate the x minus 1, so you will have 1 only, right? So you have the second line. So when you get the second line, then you have to simplify them. So you simplify them, then you will have this 1 over x. So next, what happens if we substitute the x as 1 into here? So you will see that 1 over 1. So 1 over 1 will give you the answer of 1. So this is the answer for example 1. So now we are in the example 2. So in example 2, what we have here is you have the x approaches to the positive infinity. So if you have positive infinity here and positive infinity here, so then you have a form of infinity over infinity. Okay, when you have the form of infinity over infinity, that is the quotient form again. Quotient form, infinity over infinity. This says that you have to apply L'Hopital. So we're going to apply L'Hopital. If you apply L'Hopital, so you will have to differentiate the numerator and the denominator. So if you differentiate this one, so you will have 1 over x, and if you differentiate this one, you will have 2. So we have the next line. So then you have to simplify them. When you simplify them, you have the third line. So what happens if you have 1 over 2x and you have the x approaches to the positive infinity? So you will have this. So you will have basically 1 over infinity. So if you have 1 over infinity, it's actually give you the answer is 0. 1 over infinity is actually equal to 0. And here you have 2 multiplied with infinity. 2 multiplied infinity will actually give you infinity also, right? So the answer is actually 0. So we go for the third example. So at the third example, so we have this one. So we have e to the power of x plus x, and you have x squared plus 5. So what happens if you substitute the x as infinity in here? So you will see that you have a form of infinity over infinity. E power of infinity is actually give you infinity. Infinity square will give you infinity also. Infinity plus with 5 will give you infinity back. So basically we end up with infinity over infinity also. So we're going to apply L'Hopital rule. So L'Hopital rule says that you have to differentiate the numerator and denominator together. So what happens if we differentiate the numerator? So ex, you differentiate, you have ex also, and this one will give you 1. And how about the denominator? Denominator, if you differentiate, you have 2x. This is actually 0. So then we have the next line. So now let's just see what happens when we have the limit x approaches to infinity. So you will have the form of infinity over infinity again. So means that what? It means that when you see this infinity over infinity again, so you are still under the case of quotient form. So you have to apply the L'Hopital rule for the second time. So apply the L'Hopital rule for the second time. So now you differentiate the L'Hopital rule. You differentiate the numerator, so you will have ex, and you differentiate the denominator, you will have 2. Okay, and now let's just see what happened when you have the infinity. You substitute here, so you will have infinity over 2. So e power of infinity is equal to infinity. That's why you have infinity over 2. So that is equal to infinity. So this one is actually not under quotient rule. So directly we can say that your answer is basically equal to infinity only. Now we go for the second type of indeterminate form, that is you have 0 multiplied with infinity. That one is under the product form. So when you see the product form, the first step you have to do is either you're going to use this one or you're going to use this one. So let's look at the first example. So you have the limit x approaches to 0 from the right, and you have x multiplied with ln x. So what happens if you have substitute the 0 inside them? So you see that you have 0 multiplied with ln 0. So 0 is give you 0, ln 0 approaches. So you have the limit x approaches to 0 from the right. Ln 0 will actually give you negative infinity. So you have a case of 0 multiplied with negative infinity. So you have this case. So when you have this case, so you're going to apply either this or this. So what you have to do is, you can see that I already highlight my x here. So you have to drag down your x. They become 1 over x. So when you have 1 over x, then let's just see what happens if you substitute the 0 here. So you will have the ln 0. So ln 0 is minus infinity. And you will have 1 over 0 here. So 1 over 0 is basically equal to infinity. So you have a case of infinity over infinity. Infinity over infinity, that is the time you're going to apply L'Hopital rule, because it's actually in the quotient form. So we're going to apply L'Hopital rule. So if you apply L'Hopital rule, you will have the third line. So this is what I get from the L'Hopital rule. Okay, so I differentiate whatever at the top, and I differentiate whatever at the bottom. And now let's see what happens if we simplify them. So if you simplify them, so you will have this. You have the line number 4, you have negative x. And then if you substitute the x equal to 0 into here, so you have the answer that is 0. Now I want you to pause the video for a while and see whether you are able to get the line number 3 and line number 4 by yourself. There are some steps I already skipped. Okay, so I want you to try and see whether you can get them. Now this is the example 2. So for the example 2, so if you substitute the negative infinity into here, so you have negative infinity with e power of negative infinity. So negative infinity still be negative infinity, but e power of negative infinity is basically equal to 0. So you have the form of negative infinity with 0. So this is under the product form. So you're going to apply either one of them. So we're going to apply them. Okay, so you apply them. You can see that I already highlight the e power of x. So when you highlight the e power of x, so it means that I have to drag down the e. So it becomes e minus x. Okay, so you drag down, it become minus. Okay, and then let's just see what happened. If I substitute the minus infinity into them, so I will have a result of negative infinity over infinity. Okay, where the you have e minus x, right? So your minus and minus infinity will give you a positive infinity. So e power of positive infinity is basically infinity also. So you have the form of quotient. Okay, indeterminate quotient form, and that means that you have to apply hopital rule. So you apply hopital rule means that you have to do differentiations at the numerator and denominator together. So if you apply, okay, so you differentiate this one, you have 1. You differentiate this one, you have minus e minus x. And then simplify them, so you have this. And let's just see what happens if you substitute. So if you substitute, then I will have e minus e negative infinity. So that is actually give you 0 because e power of negative infinity that is equal to 0. So now pause the video for a while and see whether you can get the line number 4. Now I want you to try these discussion questions. So there are 4 questions. So you come across the indeterminate quotient form and you will come across indeterminate product form. So try this by your own.